This is the third part of Chapter 2. Hopefully I've got the frog out of my throat that's been plaguing me for this lecture. Reflecting on the tickets machine. This is something that was in a separate demo or discussion that we could talk through, but the concepts are still here. Their behavior was inadequate in several ways, talking about issues with that. How can we do a better job? Think about things like that. Making choices in everyday life. If I have enough money left, then I will go out for a meal. Otherwise, I will stay home. So what this is talking about is how can you control the flow of code to be able to do something? How could you have made that ticket machine work slightly better? Making a choice in everyday life. If I have enough money, I will go out for a meal. Otherwise, I will stay home. Would be an example. Now what we did is we kind of created Java pseudocode for that previous slide. So in this case, if is a key word. Can't use this as a variable in Java. It'll think you're doing something. Open and close parenthesis. These four characters must come together. This brace is actually optional. They're encouraging you to put in the brace, as will I, because by putting in that brace, it ensures consistency in the way you're doing it. We'll talk about things later on how you can make a mistake if you forget to do that, even if there's only one statement. Do these statements, else or otherwise do these statements. So real life example of this, if open parenthesis amount is greater than 0, amount is passed in as what? A parameter. If it's greater than 0, then do this. In other words, if someone passes in that it's a negative 27 amount, you don't want them to be able to take money away from you. Otherwise, print out something saying it's not okay. So through the use of a conditional statement, we can avoid making a mistake or allowing something that shouldn't happen from happening. Taking a recap of what we've talked about, variables are what? Variables are temporary storage that exists in memory only as long as it's needed. In other words, if the class goes away or if you stop running the program, so will the values. They store values for the life of the object, which is what I just said. They're accessible throughout the class. Now remember, there's different types based on visibility. Okay? Parameters are another sort of variable. They're all variables in my opinion. Fields are defined within the method. Parameters are defined within the method header, if you will. They receive values from outside. They can help methods complete its task. Each call to the method receives a fresh set of values. In other words, every time you call that method, if it takes parameters, every single time you're going to send in a parameter. Okay? Now we're talking about scope highlighting. Scope is an incredibly important concept that does make a difference. Effectively, every time you see a brace, you have a new definition of scope. So here's scope, etc. Okay? Something that's defined within a set of braces is only available while those set of braces exist. So if I define a variable here, or a field, it's only in existence between these. If I define one here, it's existing between all of these. Each block of code defines new scope, which is what I just talked about, in a class, method, and a statement. You can have braces within braces within braces if you want. It's not wrong. Scope may be nested, which is what they're talking about here. Scope is static. In other words, if that's the start of the brace and this is the end of the brace, that's static. It doesn't move. You can't have an if statement moving a brace. And the lifetime is dynamic, meaning that it only exists during the time that the class is in memory and running. So while it's an instance of an object. How do we write a method to refund an excess balance? So in this case, return amount left, return balance, clear the balance 0. Would that work in your opinion? Pause for a second and think about it. Think about what the return statement does if you went through the reading. So the return is actually going to exit the code, so this line would never get executed. Methods can define their own local variables. Nothing surprising, we talked about that already. Used for temporary calculation. They're only accessible from within the method because they only have scope. Why? Because they're between those braces. Int amount to refund. No visibility modifier. Note that. It wouldn't make sense because within here it only exists at this point, so why would it make sense? Amount to refund equals the balance. Balance equals 0. Amount to refund. Okay? That's the right way to write this. Scope and lifetime. Scope of a field is its whole class. In other words, if it's defined at the class level, it exists for the life of the class. If it's defined at the method level, then it exists for the life of that method. Life of a field is the lifetime of its containing object. In other words, when it gets put in memory. The scope of a local variable is the block in which it is declared. So what they're basically saying is a field is at the class level, and a local variable is only within braces past the top, outside the initial braces, or way up the top of the class. That's fine. You'll find that a lot of people just talk about variables altogether. Many developers will understand it if you use the different terms, but variable and a local variable will be roughly the same thing, except they'll know that local variable you're referring to a smaller unit of code. Lifetime of a local variable is the time that it's within those braces. Okay? So field, by their definition, is at the top. Variable, local variable specifically, is between braces. Reviewing what we've talked about, the class bodies contain fields, constructors, and methods. Okay, so in the body it has those. Fields store values that determine an object's state. What's the state? The state is a collection of all the fields, the stuff at the top, for the entire class. Constructors initialize objects, particularly their fields. Methods implement the behavior of objects. Fields, parameters, and local variables are all variables, and that's what I was talking about before. Field is more specific, and you're exactly specifying what, and parameters, you're specifying exactly what, but they all fall under variables. Fields persist for the lifetime of an object. In other words, when that object is in memory, or an instance of it exists, that's when this matters. Local variables are used for short-lived temporary storage. In other words, if you put it inside of a brace, it's for the purpose of that brace and that brace only, or brace pair. Parameters are used to receive values into a constructor or a method. They're, from the calling code is another way you can say it. Methods have a return type, always. That return type might be void, meaning don't look for my value because you're not going to get it, or non-void methods such as int or other things that we'll learn about in a little bit. Non-void methods must have a return statement. In other words, if you say int space a function name or a method name, that must have a return value, and it must be int. Correct behavior often requires objects to make decisions. We're talking about the if statement here. They have to evaluate to true or false. One of the gotchas that we'll talk about at another point is you need an equal sign. So if a variable equal 5, that is working. If you do a variable equal 5, that's an assignment statement, and it will actually give you some really interesting results. So please, please be careful of that. It's a common mistake for even the most senior developers, and you'll spend hours doing it. With that, that's the end of part 3 of chapter 2. I hope that you got something out of this lecture. As always, if you have any questions, please do not hesitate to email me, and I will do my best to help you.